Hello there, I'm your host Dan Rojas, and this is part 2 of the Make Your Own Solar Panel video series that we're doing. In this video, I'm going to be explaining the basics of solar panels and exactly why you're doing what you're doing. So this is for the total beginner who has very little experience with electricity, that sort of thing. And also, I'm going to be showing you a little trick on how to extend the life of this stuff so you don't use a lot of it. The stuff's expensive. It's about $40 a pound. This is a quarter pound here. This is lead-free. We're going to get started with this. When you put these cells together like this, each cell is 0.5 volts. So what you do is, a big misconception about solar cells is that one of these is positive and one of these is negative, or the anode and the... Anyways, the front is one polarity and the back is the other polarity. So if you look at these panels, this one's tabbed together. Both of these are one polarity. They are the front, and the back is its own. So these panels are very similar to watch batteries. These are 1.5 volts. The panels, each cell is 0.5 volts, but the cells have a much higher current. These have a lot less. When you take a 1.5 volt battery and you put it one end to the other, this is the positive, the back is the negative. When you stack these back to back like this, what you do is you stack the voltage. So two together like this is now 3 volts. If you went to 100 of them, you would have 150 volts at the end, very low current. But you can stack the voltage that way. We do this with solar panels. Each solar cell is 0.5 volts. So our goal is to get to 18 volts to charge a 12 volt battery, which I'll explain in just a minute. But when you go back to front with this, you stack the voltage. You go 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. So two of these is 9 volts. These other two are 9 volts. That makes up 18 volts. It can vary a little bit. It can be like 17 point something depending on the resistance in there and how well you put those together, but it's generally really close to 18. The reason that you do that, you need 18 volts to charge a 12 volt battery. When you put a load on these, that 18 volts is open with no load on it. When you put a load on these, it drops down to about 14 volts. A fully charged 12 volt battery is just above 13 volts, 13.5 depending on what it is. So this panel needs to have a higher voltage to push the electrons into the battery to charge it. A charge controller protects the battery because when the battery gets up to 13.5, 13.6 volts, when it's fully charged, these have less resistance and they will continually raise the voltage in the battery all the way up to 18 volts, and that will burn your battery up. I've destroyed batteries that way by not having these hooked to a charge controller. So you definitely want to use a charge controller. It's easy to forget. Say I'm just going to charge it for a few minutes. You forget, come back, your battery's trashed. So you don't want to do that. Always use a charge controller. So that's why you need the 18 volts with this. If you have a higher voltage system, you need to put more of these in series. Now once these are in series and you have 18 volts, you can then take the whole panels and put them in parallel, which I'll explain in a future video. For now, we're just talking about series. So what we do is we go back, front, back, front, back, front, all the way down. We end up with the back over here. This is a bus wire. This, we go ahead and hook together. The back of this one hooks to this, comes over. Both of these go to the front of the next one. So we're going back, front. So we start the process all over again. So this ends at 4.5, 5, 9. When we come up here, we would put another piece of bus wire here, come over, so we go back to the front, all the way up, and then I need to add some tabbing wire here. We're going to have bus wire here. So you have the front of the panel ends up here with this connector, and way over on the other side, the back leads come off, and that creates your one long chain. Alright, so just to be clear, you want to hook one to the other. You don't want to do another boneheaded things that people do is they'll hook them here and then they'll hook them down here. You don't do that. You go over. I haven't done that, by the way, to this one. So you want to make kind of like an S, over, boom, back, and that way. So this end here is hooked together. Coming up here, these will not be hooked together. These will. So zoop, boom, boom. I hope that makes sense to you new people at this. So what you do is you measure the optimal distance between these two. This is bus wire. Same thing as tabbing wire, identically the same thing except for it's thicker. It's thicker because it handles a heavier current. It's taking the two of these and putting it to one. So it probably doesn't need to be this thick, but that's how it comes. That's what they do, so we'll assume it's close to optimal. You want to cut it just a little bit longer than what you need. And what I usually do, you can weight these down. There's a whole bunch of different methods that people have on doing this. I personally like this method. You get it in position. You want it to be close. You don't want it to be way out here. You don't need it way out there. You want it to be close enough to where if you goof up, you've got a little bit you can snip and work with without having to redo that one. What I usually do is I'll line this first one up and then just put myself a small piece of tape there. That stops all that shenanigans from happening. I'm going to make sure these are lined up appropriately where they need to be, because once you put this on, and I'm going to move this a little closer actually. Let's see. Scoot these guys down. Damn it. Well, I just destroyed my first cell in the line. So we got to redo this one. That's the disadvantage of working with broken cells. I don't know if you can see that. If you punch a hole in it like that, it's a good idea to just replace the cell, because that's gonna screw your overall power up. If they're cracked, as long as all the cells there, you're fine. If big chunks, if a little bit's missing, sometimes you buy them with the corners missing, not a big deal. If you have a big hole out of the center or big corners chipped off, don't mess with that. It's better if you have all cells that have similar breakage. That'll work pretty good. So we're gonna tape this down. I will replace that cell later. But what I usually do is tape it down like this. These should actually be closer to this. So that's the distance. That's a good distance right there. The closer it is, the better, sort of, because your panel is going to be smaller overall. So this is pretty simple here. You just need something to hold this down. They're both tin, so they actually stick very well to each other. It's going to be tricky to do this without blocking the camera, but we'll see what we can do. So once they hook together, that is a firm connection. See, it actually lifted the tape up because it heated all down the wire. You can use your thin foil that we made. If you're going to do that, you want to make sure that the junction's good. You want to make sure all this stuff's flat, nice and tight. And we are just going to put that in there. What you do is you put it between, press it down, and you don't need much. Once this pulls away, you know you got some on there, and then this will actually make the junction easier. You want to make sure when you do this, it's easy. You see how that lifted up? That's because I heated it. So what I'm going to do is show you how to use these for this part here, actually. This is, if you look, I just put a little tiny glob on there. Just virtually nothing. And this is going to work a lot more efficiently. So we're going to do this in one nice shot. Done. Done. Off. And you can actually see it change colors to know that it locked up. So once it changes colors, when it's molten silver, it'll pull right off on you. That's why you want to drag the wire down. And those are done. You want to make sure when you do this, the fronts are real easy to heat up too much and it'll lift it right off. So you just go right there, over, and that's locked down. Those are together. We're going to do this one. And that part's done. You just take a pair of scissors, snip these off, and you can use those for something else. Don't throw any of the tinned wire away because there's no sense in wasting it. And that is how you put the bus wire on. So now what I'm going to do with this one, this is one that is off the other side. I pulled some of these up just to show you. I don't know if you can see these over here, but I lifted up some of the connections with the iron just to show you how well these little pieces of thin foil works. So what you would do is they basically just fall right off. So you don't have to, you see how quickly that is? It just falls off like nothing. You smear a little bit on and those are done. So when you come along here, so I have tabbed everything together, and what we need to do is put a last set to go off of here, and the panel will be completed. It starts in the front, finishes on the back. So what I usually like doing is putting a piece of bus wire, taking the two tabbing cells at the very end and folding them over so they have a nice connection and they're connected together. This lessens the chance of you pulling them off, because at this point it gets a little tricky to handle the cells. So we did it on both sides. We are all the way up there and down. I'm going to take this out and give it a quick little test in the sun. So despite the fact that the back looks like a taped up mess, this is how the front looks. Very pretty panel. I'm going to test the voltage really quick in bright sunlight. By the way, the backs of these are usually positive and the front is usually negative on these. In the next video, we'll be encapsulating these and adding the wires, the main wires to it. I'm your host, Dan Rojas. Thank you for watching and enjoy our videos.